I think to use end, you have to use a F. So F is a command for one. Probably not.
So I'm Shravan from Digital Technologies, New Delhi.
Maybe input binary
I'll be demonstrating
or output
NetSim
and
Network Simulator and its various features and functionalities. So this tool allows users to design, analyze performance, and validate networks, and also permits the user to edit the network protocols. So first of all, why we use NetSim software or any other tool for designing any network? So, as you know, with the advancement of technology, newer protocols are being drafted very frequently, and it is very difficult to keep abreast with the latest happenings. So, analyzing these kind of network behaviors using traditional analytic method has become very tough. So, it is not easy to manually analyze the network, and considering the fact the large number of parameters involved, we have to use such kind of network simulators. So this is the introduction of NetSim software. NetSim is a scientific tool for designing and validating networks and protocols. Hence, has a lot of relevance in protocol research and development. And in defense also, there are some research that we can do with the NetSim software. And since there are a wide range of technologies possible to simulate NetSim, like Ethernet network, which has WAN, wireless LAN, MANET, file ad hoc network, WiMAX, cellular network. Cellular we have Ethernet, DVMA, cognitive radio network, ICU network, wireless sensor network, USB network, and network. NetSim has two versions, academic and standard version. So in standard version, users are provided with include network protocols. These are implemented based on the IEEE and IETF standards. So the purpose of this tool enable the user to edit the standard protocol code according to their implementation. So that they can create their DLL file and link it with NetSim. Now NetSim customer segment. NetSim has a huge number of customers varying from industries where it is used for network design and validation to defense labs where it is used for network-centric warfare simulation. It is also used in R&D labs for protocol development and new technology testing. Many PhD research papers are being published by utilizing this tool. NetSim has an academic version which is to be used in network labs of undergraduate curriculum and advanced network labs of graduate courses in electronics, computer science, and other related fields. It is being used in PhD thesis and research projects. This slide is the architecture of the NetSim software. You can see users can design the network and configure it in GUI, which will be simulated by NetSim engine and thereby provide multiple metrics. Like we can see, there are some metrics, event trace, packet trace are there. So, as you can see, it is utilizing a virtual stack. Virtual network stack is there, which actually mimics the real world TCP/IP stack, and hence make it very easy for any user to edit protocols. So it is very helpful in designing those protocols. Furthermore, user can also perform research on cross-layer protocols like Leech and MANET. Then there are some standards implemented here in NetSim. NetSim is divided into modules, or we can see in components. So standard version users can make a selective choice while using NetSim. This is a list of contents, each component and the corresponding IEEE and IETF standards. So for illustration, component 1 has internetworks. Like you can see that WAN, LAN and wireless LAN, Ethernet, IEEE standard 802.1, EBGMC, all the standards are given here. So, component 2, component their legacy networks are given, like Aloha, Protocol, TCP, Token Ring, and their corresponding international standards, IEEE and IEEE. Yes. In component 3, we have BGP networks, Border Gateway Protocol. Component 4, we have advanced wireless network, that is MANET, which contains the DSR, AODV, OLSR, ZRP, and WiMAX protocols. In component 5, we have cellular networks, which contains GSM and CDMA. And these are the international standards. Then in component 6, we have wireless sensor network and personal area network. Then component 7, we have wireless radio network. And component 9 contains LTE networks implemented according to 3GPP standards. And finally, component 9, the military radio. Then there are some features updated in the latest version of network. We've added protocols like LTE, was like BGP, systems like dynamic metrics are there. We can drafts on specific and link. Then UI property view is there. BGP and cellular network. But models are DSSP and email and SMS. Network we can get traffic load. There are some systems like HTTP, type of packets, and there are 3 methods added: peer-to-peer, email, and SMS. So we have divided this let's say 2 parts. Then first part, we have model, simulate, and analyze a variety of networks. In part 2, we have designed the network to any protocol. Part 1, to design the network, configure the network, then model traffic, which will generate some kind of traffic on any node, then simulate it. So first one, we can see some screenshot of simulation. Summarize this, the same very easy, you can drop devices and configure them in UI. You can also model multiple traffic of various types like TCP, HTTP, SMS, among more. And right clicking on the property, we have the screenshot. You can see there are various types of properties like email, volume, various kinds of applications can be made also. Command line simulator. Let's say we can do the simulation through the command line interface or through the GUI. GUI, it will create an XML file. This file is very quicker to understand, better presentation is there. We use the GUI version, but if you want to use the CLI, now analysis. Analysis, we have performance metrics, packet animator. Packet animator provides the animation. When you simulate a network, it will create a animation player in which when you play the simulation, it will show you the packets moving from one node to another. So this is the performance matrix. When you simulate any network, it will create a performance matrix. In this there are network metrics, application metrics, link metrics, protocol metrics, and device metrics. So in network metrics is the summary of the whole network. Okay. In application metrics, there is a throughput, overall throughput of your network. It is being given there. And in link metrics, you can have the information of the overall links which are being used in the network. Then in protocol metrics, you will have the information of protocols. Then in device metrics, you will have the information of the nodes which are being used in the network. This is the packet animator. There you can see in the screenshot there are some packets moving from one node to another. So it enables users to watch traffic flow through the network for in-depth virtualization and analysis. Okay. So you can change the animation speed, play and pause. These are given there. There are some analyses which are exclusive in standard version. Traces. NetSim allows users to generate some trace files which provide detailed packet information useful for performance validation, statistical analysis, and custom code debugging. Packet trace logs a set of chosen parameters for every packet as it flows through the network, such as arrival times, queuing times, departure times, payload, overhead, errors, and collision, etc. So these are the information which has been given in the packet trace. So when you simulate a network, I'll show you after the presentation. You'll have the look of this packet trace and this event trace also. So then event trace records the every single event along with associated information such as timestamp, event ID, event type, more in a text file or .csv Excel file, which can be stored at a user-defined location. So when you use this trace file, you have to enable it when you do the simulation. Give the file name. Then dynamic metrics allows user to monitor the value of a parameter over simulation timing. This is very essential for researchers to understand the behavior of a network at any instant of simulation time. So as of NetSim, link throughput, application throughput, and TCP congestion graph can be dynamically plotted. So these plots can be done offline or during simulation. That has the provision when you do the simulation, it will show you option during the simulation or after the simulation. So when you run it during the simulation, it will slow down the simulation. So we'll better choose after the simulation. So there is a Wireshark application you must be know. That Wireshark is a free and open source packet analyzer. It is used for network troubleshooting, analysis, software and communication protocol development. So in NetSim, instead of performing some mathematical calculation and providing the result to the user, it actually generates the packet and transmit it within the simulated network. So Wireshark can be used inside NetSim to capture these packets at multiple node location and perform further analysis. So when you enable the Wireshark on any node by choosing the online tab, it will automatically start during the simulation. It will capture the data packet. So go to the part 2, it is development platform, which is available in the standard version only. There we can see two screenshots. One is in programming, one is in GUI. Okay. So NetSim allows the users to edit the protocol source code, and these three codes are provided within the tool. So user can also third-party ID tool like Visual Studio 2010 to debug the protocol code. So NetSim allows the user to write the custom code for all the protocols by creating a DLL, dynamic link library, for their custom code and replacing NetSim's default DLL with the user's custom DLL. So that I'll show you in the further part. These codes can be accessed through the NetSim installation directory that is given there. The program files in NetSim standard. So in order to reduce time and effort of protocol developers, NetSim provides APIs which can be reduced to perform activities like packet creation, deletion, IP address comparison, and many more. NetSim also provides a manual in the help section to assist developers while writing or editing the source code. So these are the APIs given like packet.h, stack.h, list.h. These are the APIs which will be helpful in the designing part of NetSim. There are 300 plus customers across 15 countries given here. Some of the examples are given here. There are many lists which we have provided. Now we'll go to the software part. When you open the software, this is the first window you will see.
Did. Unmuted.
Now you see the software, you will see the simulation. Simulation, there is for opening any network, they are new. Then internetworks. Internetworks, you can design some wireless and wired node networking. Then in legacy network, we have pure Aloha, slotted Aloha, traditional Ethernet, token bus, token ring. All these we can design in legacy networks. Then in advanced network, we have MANET, WiMAX. Then BGP network is there. Cellular network, we have GSM and CDMA. Then wireless sensor network. And in personal network, we have ZigBee, cognitive radio network, and LTE network. So we just choose one internet network. Here we can see the environment of the software. So there are some nodes given here. You can see in nodes, there are wired node, wireless node, and some of the nodes are disabled. So when you enable the technologies related to these nodes, then it will be enabled automatically. So these are the enabled nodes in internet networks: wired node, wireless nodes, switches, routers, links, access points. Okay. So when you click on any node, you can place them on the environment. Then have the switches, then one router. And you can have an access point to create a wireless link to the wired. You can connect wired node. For connecting the wireless node, you have to put the wireless node. Now we can see the properties of these nodes, like by right clicking on the property. You can see some global properties like device name. We have wired node A, username, device type is there, then the position, then the Wireshark. You can enable the Wireshark from doing online. In transport layer, you have TCP, UDP. You can change this parameter from here. And for having any information about these tabs, we have the information tab given here. When you click on this I tab, you will have the information of any of the properties given here, like MSS, maximum segment size. There is a definition of MSS, formula, any kind of information about these properties you can see from this I tab. So now we want to send some generate some traffic from one node to another. So we'll drop this application tab here, right click on properties. Like if we are sending the CBI type of packet from source 1 to destination 6. We can choose the packet size, distribution, the values. Then enter arrival time, the packet arrival is there. Values can change. Now you can see from node 1 to node 6 we are sending the CBI type of packet. Hello. Hello, Nirjit, can you hear me?
Yes.
Hello everyone, can you hear me?
Yes.
Yes.
Now, like the nodes, we can see the link properties also. Here, link type, link medium, link mode. You can change the uplink BER, downlink BER to no error. You choose no error. You can see the wireless link property also. Like you can change the channel characteristics, fading, shadowing, fading only, line of sight, no path loss. After setting these parameters, I've told you about the packet trace, event trace, dynamic matrix. These analysis can be enabled by clicking on it. Choose the file name stored there. And there are some attributes on which packet trace will generate the result. Wireless LAN TCP, click on OK. Then for event trace, Name. Then there are then in dynamic metrics, you can choose this all link, application throughput, and congestion reduced protection. We choose the plot graph application. Now, if you want to enable Wireshark, you can enable it here. You can do the online. It will capture the TCP packet. Parameters will run the simulation. So just take some simulation. Whether to record the animation, medium record, or don't see anything. So you want to see the simulation, so you just record the. We have enabled the Wireshark, so it will start during the simulation and capture the packets. You can see here we are capturing the packets, TCP packets. Still running. Creating dynamic metric graphs. Now, after the simulation, it will this metric will be created. It's performance metric. In performance metrics, there are network metrics, link metric, info metric. Okay. Network metric is the overall network performance, recent timing, packets transmitted, get error, packet flighting, and bytes transmitted. Link metric, application of the link. The link ID transmitted over the links, error packets, collided packets, and then application metric, overall throughput of the network. Here we can see 0.58. The packet is transmitted from then we can see the throughput. Slide the dynamic metrics. It will create the graph for these links. Link 1, link 2, link 3. Application 1. This is the overall throughput. See the application throughput graph. And TCP congestion. You can see the packet animation. We play this. The packets come. We have created a CBR type of application on Python 8. Node 1 2. Getting the acknowledgement to send the packet. Simulation. Now we have chosen the packet trace and event trace. So we can see packet trace. Here we can see the information of the packet transmitted from port 1 to destination 6. See packet type is packet, confused, destination, the receiver. Packet type, we have chosen the CBR type of packet, so CBR packet will be moving from mode 1 to 6. Is given there. All information is given here. Each and every packet has the information.
One side line,
One side.
one side.
Event trace also. We have the information about the events. Event type, and the event type, device type, nodes and switches, all the routers, access point, all this which device type, packet type, protocol, all this information on all the events is given in the event. To save this code, there is one more part in Honest Metric. There is NetSync Analytics. We have different networks given here, like internet network, multi-network, UGC. So this is the tool to compare the result between different experiments. Like we choose the different metrics files from here. Matrix file is given. We have to choose the matrix file. So this can be shown in graphs like solution timing, packets transmitted, packet alert, packet collected, bytes transmitted, payload transmitted, overhead transmitted. So this is the graph of a single matrix. So when we choose the multiple matrices from here, we can compare. So this is a comparison purpose. You can compare between different metrics. So these are the metrics come after the simulation of different networks. They are same network, inter-network, but their parameters are different. So we'll see the variation in the results. Likewise, you can choose the metric file of every network. The comparison between. Okay. Now we can edit some protocols. I've told you that this Netsim standard has good facility. So when we go into the installation directory of Netsim, here in the program files Netsim standards, then SRC, we have programming and simulation. So we just make a copy of the simulation folder just to make sure that our original simulation file is not hampered after doing any simulation in by editing any protocol. So we'll have a simulation copy of this folder. Here we can see some all the protocols which are being used in the NetSim are given here. So when we open this NetSim, which is linking to the Visual Studio, it will show you all the protocols here in the Visual Studio. All the protocols, right from the AODV application, ARP, ATM, cellular, DR, DSR. So I've opened one DSR.c program. Okay. Here I have written one printf command, printf hello world. Okay. Hello world. So when we run the DSR protocol in the CLI mode, it will show you this hello world message there. It will show you that whatever you have edited in the protocol, that will give coming into the GUI. So when you enter this, the simulation will run after that. Okay. So by giving this hello printf command, you have to build it. You have to build it. I've already built it, so I'll show you the where the file is in DLL folder. DSR.dll file. When you build it, it will create a libdsr.dll file. So that is the same file which is being used in the netsim bin directory. Here in netsim standards, we have bin folder. In bin folder, we have the DLL file of all the protocols which are being called to do any simulation related to these protocols. It will call this DLL in the simulation. So in this bin folder, we are seeing that libdsr.dll is there. So that is the same DLL. I've copied it from there in the DLL folder, and this is the libdsr default folder. This is the original DLL folder, original DLL file, but I have renamed it for default DLL so that our original DLL does not vary. So when we run any simulation related to DSR, I'll show you. Like we use the Manet. Now Manet will call the DSR protocol. So here in properties we are sending the CBR type of packet from source 1 to destination ID 5. Okay. So when we run this simulation, it will generate CBR type of packet on node 1. Before that, it will call that libdsr.dll file, and it will show our hello world that printed. That will show in the CLI command. When we run the simulation, here we can see the command prompt. Hello world is printed here. So we have edited that protocol by writing the command printf hello world. So that is printed here. When you enter it, it will then run your simulation. So that is just to show you that we can edit any protocol and link it with NetSim GUI. So after that entering, you will original DLL is there. So this is example of Manet using that libDSR.dll. So all other parameters are same for any network, like network matrix, link matrix, queue matrix, application matrix. All these are generated on the same pattern. Here we have not included the packet trace and event trace, so it is not generated here. There is one more part of in NetSim. There are some protocols given in the programming that have the combination of both programming and GUI. Here you can see in cryptography when you choose substitution. We have two windows. One is for choosing these modes. In sample, we have this as sample programming that can be used, and there is a user mode. In user mode, when you choose the user mode, then you have to choose the exe file. Okay, so that exe file you have to create in Visual Studio, and then you can link it with NetSim GUI. Okay, so I'll just show you an example. When you do the encryption part, run, create that plain text to the ciphertext. Now we choose the decryption, then it will create the ciphertext to the plain text. So that is the programming given in the backend. You can see from here in interface source code, when you click it will open the program in the Visual Studio. Also, we can see the concept, algorithm, pseudocodes, and flowchart of this sample programming. To see it, we choose this. We can see the concept behind. That is for a student for seeing the theoretical part. When you see the interface source code, it will open the code in this Visual Studio. So we can add it and create its exe file and link it with NetSim GUI. Okay. So likewise, we have some other examples. Like we choose shortest path. We can choose the algorithm, link state or Floyd, number of routers we can choose here. We have to give the distance. Now we have to choose the source and destination router. Let's say router 1 is source and 3 is destination. Then when we run it, it will show you the shortest path which is being used in the communication. Here you can see this 1, 2, 3 is the shortest path. It is being calculated by this backend programming. Okay. So there are some help manuals given, user manual, source code help, and experimental manual are given, in which there are 23, 24 experiments which are being used on the different technologies given. You can use it while using the simulation. Okay. So this is a small presentation on NetSim software. If you have any query, you can ask me.
Right.
Or you can mail us your queries. Hello.
Hello.
Hello. Yes, sir. Hello, Rajat sir. Hello. Hello, Nirjar. Hello.
Yes, hello, Shravan. Hello.
Yeah. There is one query.
Fine.
There is one query from sir.
Hmm?
Can we have? Can we design? Can we access the information of other layers to run a cross-layer simulation?
Yes, it is possible. As a matter of fact,
Mhm.
in Leech we are doing that only.
Okay.
So Leech, what we have done is,
In Leech, you can do the cross-layer simulation.
yes, cross-layer is possible.
Okay.
Uh, you can, no problem. Let me check. Any other queries?
Yeah, I'm just. There is one more question, Nirjar. Hello.
Yes.
If we want to run a simulation of 100 nodes, then can we run it through source code? As it configuring a topology manually seems difficult. Sir has asked question. So I've answered them that using XML config file we can use it, or some other options are
In
there.
NetSim, uh, we prefer the graphical user interface mode, as it is easily you can configure specific nodes.
Okay.
You can also write in the Excel file. I'm very sorry, XML file.
XML file.
Both are possible.
Okay. Okay. Through C source code it is also possible.
No, C source code is only for the protocols.
Okay.
But designing the network,
Design network you
you
have to
can
use
do
the
it either
XML.
graphically,
Okay.
XML, or you can do it graphically,
Okay.
like click and drop.
Click and drop. So when you're not using the click and drop, we can use it in XML config files. No?
Yes, but we would prefer you do it graphically, click and drop, as it is more easier.
Okay. Okay. Nishant?
I would like to add one. Yes.
The sir has asked us how can we simulate cross-layer simulations. So that is in the Leech code video that is given in your website.
Yes. So the user can access the file exchange. I'll give. Yeah, just check if you have that file exchange link. You can share with them, and they can check the Leech implementation. So what has been done in wireless sensor network for implementing Leech, that is clustering in wireless sensor network, we require the remaining power from the physical layer.
Okay.
Or rather you can say MAC layer. We require this property of the remaining power of the node, and we have to send this property to the network layer.
Okay.
So for that purpose in Leech, we have Leech is a cross-layer protocol, so we have worked on it and we have implemented it.
There is one more question. Which feature of NetSim deals with topology of network?
Sorry, can you please repeat the question once again?
Which feature of NetSim deals with topology of network?
I'm not getting the question. Actually, which feature of Netflix?
Deals with the topology of network. I mean, there's topologies like ring, bus, star topologies, all these.
Okay, so like if it's for academic purpose, like teaching the students ring bus topology, the users can go to programming legacy networks.
Okay.
So in simulation, if you go to new, you will get legacy networks. So you will get, and also you can check our experiments. If you go to help experiment manual, so you will get some experiments on ring bus topologies.
Okay.
So there it is explained in details how to implement it.
In legacy, there are that Aloha, slotted Aloha, token ring, all these protocols are available.
Traditional Ethernet.
Yeah.
Yeah, traditional Ethernet you can use it for rings and bus.
Okay.
You can show them.
Yeah, yeah. There's one more question. Can we do analysis of energy efficiency metrics through NetSim?
Yes, you can do it. As a matter of fact, in wireless sensor network, you can do it by default. No, you can do it in most of the networks, wherever energy factor is there.
Okay, like in wireless sensor network, we have the energy provision.
Yeah, we have that. We have in MANET also. You can just check the device properties wherever you can set the battery property, especially in the devices. In all those networks, you can perform energy efficiency. You can even check the I'm sorry. You can even check the battery models, how much energy has been consumed, how much battery energy left. So all those properties will be shown up at the end of the simulation.
Okay. नहीं सबका ऑन है सबका बोला हुआ है क्लिक करने में हटेगा तो
Hello.
Hello. Yes,
Yeah.
ma'am.
Can we get a yes? Can we get a recorded version of the presentation?
Yes, ma'am. Yes, ma'am. We are recording the webinar. I'll send you the link.
Yeah, because there was some problem, sound problem in the middle, so
Okay, okay. No
it was
problem.
not clear.
We'll send you. We'll send you a link, ma'am.
Yeah.
Okay, okay.
Another thing I wanted to ask you.
Yes, ma'am.
Yeah. Like as you told, like we have to drag and drop the nodes. So we have to drag and drop 100 number of all the nodes, like 120.
Yeah, yeah. If you're using the GUI, you have to drag and drop those nodes. But we have a option of config XML files. So you can
Yes.
edit those nodes in the XML files. There you can choose
Yeah.
multiple number of nodes there. So you need not drag drop all those nodes. That will reflect on in the GUI. When you choose this XML file, it will reflect in the
Hmm.
GUI also. So that will be helpful
Yeah.
while using the XML files.
And another thing is that we can also increase or decrease the speed of the nodes as we do in the NS2.
That's increase or decrease of the speed of that animation.
Means to see the movement of the nodes and the packets.
Yes, yes, there are option. I've shown you that the animation speed. We have
Yeah,
the
you have shown, huh?
yes, yes, we have the option.
Okay then.
Hmm.
Yeah, thank you.
Okay. Any other queries? You can mail me.
Okay, okay, sir. Thank you. It was really good.
Okay. Thank you, ma'am. Hello. Do you have any other query, sir? Surjit, sir. Do you have any other query? Tapas, sir. कर रहे थे बाकी चैट पे